Hello everyone, welcome to our final project presentation for course number 41416. The title of our presentation is Real-Time Environmental Monitoring System. We are group 4 of section E2. Our group members are ID 42, 43, 44 and 45. Here we will go through summary, introduction, design, implementation, analysis and evaluation and references one by one. Here, we have implemented an Arduino-based system that can measure important parameters like temperature, air quality, humidity, and can report to the cloud-based server. Now, we need to know the importance of environmental monitoring system. For environment, temperature, humidity, and air quality are three vital parameters, but nowadays temperature increase has been a global issue that is known as global warming. Air pollution is also increasing exponentially due to increase of emitting carbon dioxide, carbon monoxide, and other deadly gases to the environment. That's why our monitoring system offers a sustainable automated solution for observing environmental parameters. Now we are going to introduce the components for this project. Here we have used an Arduino Uno board, which is a 8-bit RISC processor, DHT11, temperature and humidity sensor, MT135 air quality sensor, SIM900A GSM module. We also use 5-volt relay board, each board containing 4 relays, 2 units of C4 solar panel, 2 units of TP4056 battery charging module, boost converter, MOSFET 7805 and capacitor.
Design method. The circuit that we are using consists of two major parts, one being the sensor and the GSM module, and the other is the charging part. The sensors are used to read humidity, temperature, and air quality data, and the GSM module is used to transmit the data read from the sensors into the ThingSpeak online server that we created. In the charging part, we are using 3.7 volt LiPo battery for our project. We're using two TP4056 charging modules to charge the batteries. We are using one of the two batteries to power the Arduino and the other two to power the GSM and the sensors. The battery connected to the Arduino is charged via one of the two charging modules, and the other two batteries are charged via the other charging module. The reason that we are using two charging modules is that Arduino needs to be always powered on while the sensors and the GSMs are not. We will be using 3 relays to set the two batteries used to power the GSM module in series for while discharging and in parallel while charging them via solar power. Circuit diagram. Here we can see the overall circuit diagram that we used. We are using 12-volt solar module to charge the batteries. We used a 5-volt voltage regulator to regulate the output voltage of the solar and then feed it to the charging module. The module further regulates the voltage to charge the batteries. Battery 1 is connected to the boost converter to boost the voltage to around 7 volt and then regulate it to 5 volt to power the Arduino. Battery 2 and 3 are connected to the relay board. While in discharging mode, battery 2 and 3 are connected in series via the relay connection. We can see the relay connection in the figure. 3 relays were used to implement the whole charging and discharging of battery 2 and 3. Next, to power the GSM and sensors, we used 5-volt voltage regulator and the series connected 3.7-volt batteries. The sensors and GSMs were also connected to the Arduino for processing the sensor values and transmitting the value rate via GSM module to the server. Here is the schematic that we used to implement the PCB. We used Autodesk Eagle software to simulate the circuit. We had to download libraries for each of the modules that needed to complete the design, and then we used wire connection to connect all the components together and complete the design.
At this point, we're describing our PCB layout and 3D rendering. We have prepared a PCB for our whole system. As can be seen in the pictures, the PCB has two-sided printed. The bottom side has the copper wires and the top side has text and others. The PCB 3D layout was created by Fusion 360 software, which is the 3D software for Autodesk Eagle.
The 3D rendering shows 3 pictures. On the left is the home view where you can see two charging modules, two voltage regulators, some capacitors, and some pins that are used to build the whole circuit. The middle is the top view of the PCB, and at right is the bottom view. In the bottom view, we can see the copper wirings and pin layouts.
Now we'll see our project demonstration in hardware. This is our solar. This is the PCB shield. There are 4 relays right there. This is the sensors. These are the sensors, and this is our GSM module. The circuit is now in series mode that powers up the GSM module and also the sensors. And after some seconds, it will become automatically in parallel mode, and the batteries will be charged with help of the solar, the charging modules, and the boost converter. Now the circuit has turned into parallel mode. The gas sensors are off as the batteries are now in parallel and is charging. The GSM module is also off, and the charging modules are being used to charge the solar. So this is our project. As can be seen, we have added a casing. This is the humidity sensor, this is the air quality sensor, and this is our GSM module that is now turned on and connected. This is sending data to the ThingSpeak server. Inside there are three batteries, the PCB with Arduino and relays on top of each other. And in a few minutes we'll see whole system turn off as relays set to charging mode. And this is our solar panel. Now it's not connected as there's no sunlight, but if this was connected in charging mode, it would have charged the batteries.
Now we'll hear the click when the relay turns off and the battery goes to charging mode.
So here are some photographs of our final project. This device is compact and very small and light in size. It is movable to anywhere. It is totally environment friendly. It doesn't consume any fuel or doesn't emit any harmful elements to the environment. As we have used GSM module to send the data to the server, no additional internet connection is required. The batteries used in the device is powered by solar energy. We have used ThingSpeak as our global server where the data are uploaded and saved and analyzed, and the final result is shown. This is a sustainable device indeed. We are measuring basically 3 parameters of the environment: temperature, humidity, and air quality. Air quality is actually indicates that whether the level of carbon dioxide, methane, and other harmful gases are below the threshold limit or not. For example, if the concentration of the carbon dioxide is 400 to 750 ppm, the air quality is considered to be good. If the concentration is 750 ppm to 1200 ppm, it is considered to be harmful, and if the concentration is above 1200 ppm, it is considered to be extremely harmful. Here some graphical results are shown. We can see that our device takes the data from the environment after every 2 minutes, and thus the plots are achieved. We can also change the time interval using the code. Finally, we have created a GitHub repository, and the link is attached in this slide. We will attach the link to the video later.
We are starting our analysis and evaluation part. The first topic is novelty. Our novelty is introducing a solar powered monitoring system at low cost, introducing feasible battery charging method to power both Arduino and GSM module, using relays for setting the batteries in parallel for charging and series for discharging. We also designed a completely new PCB by integrating all the components. This is the bill of materials of our total project. Here total cost is 6,555 TK. Here now we have calculated per unit cost of a prototype. From the chart we have found our per unit cost is 3,385 taka. Now we are considering our project to public health and safety. Our design is good for public health as it is health hazard free, risk free, and don't release any harmful component in the environment. We can also consider it for the environment as it is run by renewable energy such as solar energy. It also has cultural and social needs too. We can assess the impact of our project on four issues. The first one is societal issue, to control the activities of the industry so that the garbage released by them can be less. The second one is health and the safety issue. Our system is health hazard free and safe to use as it charges the battery from solar. The third one is assessment of legal issue. Our project maintains all environmental laws which goes under legal issue. The last one is our project can change people culture by creating awareness which goes under cultural issue.
As we know, every innovative work requires a big market to bring in positive change in people's life. We believe that our device is going to be the next milestone and it will bring positive changes in people's life and it will make people's life much easier. It gives accurate result. It is a compact device which is energy efficient and comes at a very low cost. We know that at this present era we cannot change our activities which pollute environment. Rather, we can optimize our social activity to keep our environment as sound as possible, knowing the important conditions and parameters of the environment using the environment monitor. Our device consumes no fuel. It is powered by solar energy and it is totally environment friendly. To make this project successful, all of us worked parallelly according to our capability. Munirul was expert in building circuit, finding out faults in the circuit, so he did that part the most. While I did the part of coding, designed the circuit to power of GSM module by connecting two batteries in series. I have also worked in making the relay system. Shubhra Chaudhuri helped in assembling the GSM module circuit. He also contributed in battery charging system and did research to charge and discharge the battery using efficient circuitry. Saurav was an expert in finding out solution quickly. He also did 3D rendering part within a very short time. We four have come from 4 different places of the country. We have different work experience and expertise with some common skills. We had logical arguments while we worked, but we managed to give our best and work together. Of course, it was an amazing experience for all of us. Before the mid-break, we had to sit in online meetings several times. We did a lot of research about the previous circuits and projects. We gathered knowledge and later we distributed the work among us. After the mid-break, we worked together in the guest room of Sher-e-Bangla Hall. We have also worked in the power electronics lab when we faced problem in battery charging circuit. We had to do some trial and error, so that part was done in the lab. Here the logbook of the project implementation and references are attached. Thank you so much for your kind attention. If you have any question, please let us know.